Every day we make thousands of decisions. Most are relatively inconsequential. For example, do you want coffee or tea? Others are much more complex, like whether you should accept a new job or move to a different city. There are lots of ways to make a decision. You could flip a coin, you could follow your heart, or you could just make a choice at random and hope for the best. You might feel like you're bad at making decisions, or not good at making good ones. However, it's something we all struggle with due to the way our brains are made. Behind every decision, there are secret psychological factors that shape the way we think and act. Shining a light on these factors can make them easier to overcome. Many missteps in decision-making can be chalked up to cognitive bias. That's our tendency to think a certain way without even realizing it. Here's a simple example. Have you ever avoided switching internet providers even though you were unhappy with your current service? Something called status quo bias might be to blame. That's our tendency to stick with what we know instead of choosing something new and different. We see the alternative as a risk, or just not worth the trouble, even if it might be better. Without realizing it, we can become overly resistant to change. That's status quo bias at work. A bias called anchoring can also affect the choices we make. To understand how anchoring works, imagine you're shopping for a used car. Now, say the dealer offers you a discount to try and sweeten the deal. Sounds like a can't-miss opportunity, right? Not necessarily. Anchoring suggests that we rely too heavily on the first thing we hear, in this case, the initial price of the car. That's what makes the discount so appealing, but it shouldn't be the deciding factor. There are also more objective things to consider, like how much the car is really worth, and whether you can find a better price elsewhere. If you're not careful, the anchoring effect can weigh you down. Cognitive biases aren't the only thing that can affect decision-making. More and more studies show that stress can have an impact, both on the quality of our decisions and our ability to make them. Take this well-known study about jam. At an upscale food market, researchers set up 2 displays offering free samples of jam. One gave customers 6 different flavors to choose from, the other 24. The small display attracted fewer people, but they were 6 times more likely to actually buy a jar of jam. The reason for this is a phenomenon now known as choice overload. Choice overload can happen anytime we feel overwhelmed by the number of options. We have such a hard time comparing them, we're less likely to choose anything at all. A similar thing happens when we're forced to make multiple decisions, one after another, and so on. We experience an effect psychologists call decision fatigue. Decision fatigue suggests that making a large number of decisions over a prolonged period of time can be a significant drain on our willpower. The result? We have a harder time saying no to things like junk food, impulse buys, and other tempting offers. On the flip side, fatigue can also make it harder to say yes, especially to decisions that would upset the status quo. We leave things as they are because it's the easiest thing to do. Making decisions will always be difficult because it takes time and energy to weigh your options. Things like certainty are just a part of the process. It's better to think carefully about your options and consider the many paths you could take. The first step to making any decision is simple. Identify the problem. As an example, say you're trying to choose between 2 different apartments. One is cheaper, but farther away from work. The other is closer and nicer, but much more expensive. Which one would you choose? Depending on what you value, you probably have some idea. This initial response, the one tied to your instincts and emotions, is perfectly valid. However, you should also try to look at your options rationally. Start by comparing them. There are several ways to do this. For example, you could list all the factors that you're considering, things like price, location, and other amenities, then choose the one thing that's most important to you. With that in mind, which option comes out on top? You could go one step further and create a point system. Take that same list and turn it into a scorecard for each option. In this example, that means apartment 1 would score high on affordable rent, let's say a 10, but much lower on location. Apartment 2 would score about the opposite. Keep going down the list until you've scored every item, being as objective as you can. Then add up the totals, and maybe you have a winner. Looking at it another way, you could evaluate one option at a time with a list of pros and cons. It sounds simple, but sometimes it helps to write these things down. This time, it's okay to be subjective. Certain factors can and should carry more weight than others. It's how you feel about them that counts, so be honest about what these things mean to you. Making decisions isn't like taking a test. There are no right or wrong answers per se, it just depends on the situation. Focus on taking the time to think about your options and what you hope to achieve, so you can feel confident about the choices you make. It's not as easy as flipping a coin, but it's worth the extra effort.
First of all, what is risk? Now, if you think about it, life is full of risks. From the time we wake up to the time we go to sleep, and even in between. For example, there are risks associated with breathing. Did you know that air pollution causes about 7 million deaths each year? There are risks associated with eating. Foodborne illness causes about 420,000 deaths each year. And then there's traveling. Road accidents cause over 3,000 deaths each day. In fact, every day we have to make constant decisions about the risks we face. Now, there are situations in which we need to know what the risk is from certain events so that appropriate action can be taken. For example, what's the risk to health from a new influenza virus, an industrial chemical accident, or a bushfire? But first, what exactly is risk? Risk can mean different things to different people and in different contexts. But in very simple terms, risk can be thought of as the product of how likely someone is to be exposed to something bad, a hazard, and the consequence, which is how bad the outcome will be. Let's have a look at an example. Say you have to cross a road and you're trying to figure out what the risk associated with this is. Let's take a look at some different scenarios. In the first scenario, our hazard is a bicycle. Let's assume there are only bicycles allowed on this road. Let's also assume that the road is not that busy and there's only one bicycle every 5 minutes on that road. Now, because bicycles don't go on that road very often, the likelihood of the bicycle crashing into you is low, right? If the bicycle does crash into you, the consequence of that would be relatively low, wouldn't it? So in this scenario, the likelihood and the consequence are both low. Therefore, the overall risk is low. Now, obviously, if there are bicycles traveling more frequently, the likelihood of a crash would be higher. But the consequence, if a bicycle did crash into you, would still be low. But what if things were different? Let's change that bicycle to a truck. Now, with a truck passing every 5 minutes, the likelihood of a crash would still be low. However, the consequence is far more severe. Now, imagine if it was a busy truck route and trucks were going on this road very frequently. In this scenario, both the likelihood of a crash and the consequence will be high, which means that the overall risk would be high. You wouldn't even consider crossing this road, right? A simple way of visualizing this and figuring out the overall level of risk is by using a risk matrix. In a risk matrix, information about consequence and likelihood can be used to determine the overall level of risk. Let's have a look at a simple risk matrix. A risk matrix is basically a table or grid with a measure of likelihood on one side and consequence on the other, graded from low to high. The combination of the two, which is the overall level of risk, can be categorized as low, medium, or high, and color-coded. So let's get back to our example. In the scenario in which there are bikes traveling very infrequently, the likelihood is low and the consequence is low. Therefore, the overall risk is low. When there are more bikes, the likelihood is high, but the consequence is still low, and therefore the overall risk is medium. Let's consider the truck now. In the scenario where trucks are infrequent, the likelihood of a crash is low, but the consequence is high. The overall risk is medium. And if it's a busy truck route, the likelihood and consequence are both high, and therefore the overall risk is high. So that's how a risk matrix can be used to determine the overall level of risk using an assessment of likelihood and consequence. There are many different types of matrices in use with varying degrees of complexity. They can have many categories and different grades of risk. They may also have different ways of defining categories of likelihood and consequence. For example, a high likelihood may mean that it's expected to occur in most circumstances, and a low likelihood may mean that it may occur only very rarely, such as once in 100 years. With consequence, a high consequence may mean multiple deaths, and a low consequence may mean only minor injuries. So, the risk matrix and the categories that are used can vary, and therefore should be relevant to the situation and context in which the risk assessment is done. Regardless of this, risk matrices follow the same principle. Although risk matrices have their limitations, such as being subjective, not being consistently interpreted, and not taking time frames into consideration, they are a useful and practical tool to categorize risk.
Hazard, risk, and safety. We all hear these terms on a daily basis. So-and-so a chemical, physical, or a biological agent poses a risk. This or that product is a hazard, or behaving a certain way is unsafe. A lot of the time, hazard and risk are freely used to mean the same thing. However, they are not. Hazard is the potential to cause harm. Risk, on the other hand, is the likelihood of harm in defined circumstances. But what does this actually mean? Let's look at two examples. First, potassium dichromate. It sounds scary, and it is indeed a hazardous substance that is both toxic and carcinogenic. It is used in some cases to analyse exhaled breath for alcohol. For this purpose, it is sealed in a tube. Therefore, although it is intrinsically a hazardous substance, if used and managed as described, it presents little or no risk to people or the environment. Now, let's look at the opposite case. Flour would not be considered by many to be a hazardous substance. However, if a baker were to be exposed over a period of time to airborne flour, he or she could develop dermatitis, conjunctivitis, rhinitis, and even asthma. So even something that is considered a low hazard can present substantial risk, and vice versa. Risk is always a probability, influenced by the level of exposure. To evaluate the risk, we have to take many factors into consideration. How, where, how much and how long one can be exposed to the hazard are all things to be taken into account. Toxicological research can map the potentially harmful properties of a product, be it chemical, physical or biological, and it can also set a limit under which exposure will have no effect. Based on this research, a risk can be calculated based on frequency, conditions, and length of exposure. However, some types of risks are hard to quantify, either because of the complexity of a system, like in the case of climate change, or because we still lack some of the tools to measure it, like in the case of nanomaterials.
My name is Jan and I work at the European Food Safety Authority, EFSA. I will briefly explain you what we mean by environmental risk assessment and why it's so important. The environment is a broad concept that describes our biophysical surroundings. It includes air, water, land, and living organisms such as plant and wildlife. Environmental risk assessment is a scientific process that identifies and evaluates threats to the environment, in particular to living organisms, their habitats, and ecosystems. The causes of environmental threats are diverse. Some are largely natural, for example, earthquakes or volcanic eruptions, whilst others might be the result of human activity, such as industrialization and urbanization. Think, for instance, about air pollution, toxic chemicals in food and water, poor housing, and sanitation. In the European food safety system, EFSA is responsible for carrying out risk assessment of products which may have a direct or indirect impact on food and feed safety. Because the use of these products may pose risks to the environment, EFSA also considers these environmental risks in its assessments. EFSA performs environmental risk assessment in a number of areas, such as genetically modified organisms, pesticides, plant pests, invasive plant species, and feed additives. The purpose of these assessments is to assess the seriousness and the likelihood of harm to the environment which might arise following a specific activity, such as the cultivation of a particular GM plant or the application of pesticides. These assessments follow several stages, beginning with problem formulation. Problem formulation is the first critical step because it defines the scope of the environmental risk assessment by specifying what needs to be protected from harm and by identifying potential harmful effects. Problem formulation is then followed by a hazard and an exposure characterization. In the hazard characterization, potential hazards and the seriousness of potential harm are examined, whilst the exposure characterization considers the likelihood and the level of exposure to the hazard, and thus how likely it is that harm will occur. The final step involves the characterization of risk. Here, the seriousness and the likelihood of harm are combined to estimate the level of risk. In some cases, the environmental risk assessment also includes risk mitigation measures. Such measures aim to reduce an identified risk to an acceptable level or a level of no concern.
When there is no consensus on the level of risk, policymakers sometimes apply the precautionary principle.
Not acting till you have a good idea of any adverse consequences is called the precautionary principle. This happens every day. Products are tested before they go to market to prove that they're safe, because there's a chance that they're not. Consider mobile phones and fears that their radiation emissions may cause cancer. If we choose to wait until mobile phones were proven to be 100% safe, or not, we would have no mobile phone technology. Cancer is not something to be taken lightly, and concerns should never be dismissed, but waiting for irrefutable data, which is logically impossible, is a bad way to make decisions. And by doing so, we may lose amazing opportunities or encounter new risks.
Tell you the precautionary principle is a cynical and ignorant ploy to prevent good things happening. To others, it is a way of avoiding actions that may lead to bad things happening. So, who's right? According to the Merriam-Webster dictionary, precaution is something that is done to prevent possible harm or trouble from happening in the future.
To remove all concerns about the risks associated with every single action, let alone those based on the complex series of tests and observations required by science.
Every time we ask ourselves what the consequences of our actions might be and what we can do to reduce the likelihood of consequences we don't like, we are exercising precaution. It seems sensible.
When we're faced with risks, it's natural to want to wait till there's 100% certainty about it. Unfortunately, that's impossible. The best that can be achieved is that given all our current theories, repeated testing, logic, and the facts, that we're reasonably confident something is safe.
But what elevates this seemingly smart idea into a principle? Turning to Merriam-Webster again, the definition of principle that best fits here is a moral rule or belief that helps you know what is right and wrong and that influences your actions. In other words, from definitions alone, the precautionary principle is a guide to taking actions now that help prevent future events that are considered societally undesirable or unacceptable. It's the ethical equivalent of saying, look before you leap.
And this is where the precautionary principle can be misused. Waiting for more information is useful, but waiting for that unattainable 100% certainty prevents anybody from doing anything.
In the year 2000, the European Commission published a 29-page document on the interpretation and implementation of the precautionary principle. It's a sophisticated and comprehensive document. A 2005 UNESCO report synthesizes many of the main points in a slightly shorter working definition. Summarizing the UNESCO definition of the precautionary principle, we have this. When human activities may lead to morally unacceptable harm that is scientifically plausible but uncertain, action shall be taken to avoid or diminish that harm. The judgment of plausibility should be grounded in scientific analysis. Actions are interventions that are taken before harm occurs that seek to avoid or diminish harm. Actions should be chosen that are proportional to the seriousness of the potential harm, with consideration of their positive and negative consequences, and with an assessment of the moral implications of both action and inaction. In other words, the precautionary principle is about using scientific understanding to take action to avoid harm that might otherwise occur, thinking about the pros and cons of this action in a broader context, and making sure that the effort behind the action is reasonable, given the potential harm it's intended to address. So the precautionary principle is not about stopping innovation or even putting the brakes on technological progress. Instead, it's a go slow and ask smart questions principle, to be applied where there are indications of potentially serious consequences if we don't get it right.
It is best to err on the side of caution. Nevertheless, the precautionary decisions should remain proportional to the potential but uncertain risk and be re-evaluated when new data become available. Indeed, the proportionality principle is and should be at the base of most legal thinking.
So what's the role of communications in this? The aim of risk communications is to provide information so people can make informed decisions about whether a risk is acceptable or not, or whether they need to take action to prevent or reduce a risk. It's about bridging the gap between science and the consumer. This is important because scientific experts and the public have very different ways of assessing risk and different perceptions of risk. Therefore, the information they need is often very different. So what does this mean? Well, scientists decide whether something is a risk or not by carrying out a very structured assessment process. It involves analysing large amounts of data to draw science-based conclusions on risks that can be applied generally. On the other hand, we, as consumers, rely heavily on perception. And often we are concerned about what does this risk mean for me, or what does it mean for vulnerable groups like babies, infants, or pregnant women?
Now, how can we manage a risk? Risk can thus be managed by limiting exposure to a danger and by the adoption of risk reduction measures. Prevention might be a better idea to reduce risk. For example, driving has been made safer by speed limits, the use of seatbelts, bumpers, airbags, driver assistance systems, etc. But what is considered safe? Acceptable safety levels greatly depend on where you are on the planet, culture, socio-economic criteria, and the sector.